Okay, let's take a look at number 4 in section 8.4. Little tricky one. Find the centroid of the region lying between the graphs of the functions y equals x to the fourth and y equal 3 times the square root of x. Be careful. The first time I read this, I thought this was y equal the cube root of x, and that messed things up. So, and we're going to do this over the interval from 0 to 1. Again, I think it's always important to sketch sketch the region that you're finding the centroid of. It makes um, for checking that your answer is reasonable and just helps you set the problem up correctly. So I graphed y equals, just on the interval from 0 to 1, y equals 3 times the square root of x, right? When x is 0, we get 0. When x is 1, I get 3 times 1, I get 3. Excuse me, I get 3. And this graph continues to increase, but at a decreasing rate. That's the top part of this region you can see I've shaded in. And then y equals x to the fourth, for values of x up through 1/2, it's very small, right? In fact, x equal 1/2. 1/2 to the fourth is 1/16. So we're just at a height of 1/16. But then obviously by the time we get to 1, uh, x to the fourth would be 1 to the fourth, or 1. So we would be right there. And then that continues to grow very rapidly after that. But just on the interval from 0 to 1, so right, we're just looking at this line, x equal 1. This is the top curve of our region. This is the bottom curve, so we're vertically simple. They do want you to round the coordinates of the centroid to 3 decimal places. So let's take a look at this one then. The mass, all right, is the density, which I'm calling rho, times the area of the region. The area would just be integrating from 0 to 1, the top function minus the bottom function. So it's a fairly simple integral to do. We find the antiderivative by the power rule, and then I plug in 1. Of course, if I plug in 1, I just get 2 minus 1/5, and plug in 0, I get 0. So 2 minus 1/5 minus 0. 2 minus 1/5 is 9/5, so I get 9/5 times the density rho. Now, the moments about the x and y axis, here's the help sheet that I'll probably give you on the test. So for a lambda with constant density, bounded by the graphs of y equal f of x and y equal g of x. So f of x is on top, g of x on the bottom, between x equal a and x equal b. Here's the moment about the x-axis, and here's the moment about the y-axis. So it's just half of rho integrating the top function squared minus the bottom function squared. So I did that here. Top function is, again, 3 times the square root of x, and the bottom function x to the fourth. So I'm going to square both of those. When I square 3, I get 9. Square the square root of x, I get x. Square x to the fourth, I get x to the 8th. And now I find the antiderivative of 9x and x to the 8th. Plug in 1, plug in 0, and subtract. And I get 79/36 times the density for the moment about the x-axis. The moment about the y-axis, I'm just going to do, right, x times the top minus the bottom function. So here I've got x times the top function member is this, bottom function this. Go ahead and distribute this through before we integrate, of course. Get 3x to the 3/2, right? 1 plus a half, and then x to the 5th here. Find the antiderivative of 3x to the 3/2. It'll be 6/5 x to the 5/2. Make sure you understand how we got that with the power rule. By the power rule, we get this for the antiderivative x to the 5th over here. And again, plug in 1, plug in 0, and subtract. Fairly easy to do, and I get 31/30 rho. Now I can find my coordinates of my centroid. The x-coordinate will be the moment about the y-axis, which we just found, divided by the mass. And remember, the mass was up here, 9/5 of rho. And of course, as always, what happens when we simplify, the rows cancel. So again, you could use a density of 1 in these problems. The density, as long as it's a uniform, dense, planar lamina, this will always happen. And then so 31/30 divided by 9/5 is 31/54, which is about 0.574. The y-coordinate is the moment about the x-axis divided by the mass. And again, we found the moment about the x-axis here. The mass is here. Again, the rows cancel. This fraction divided by this fraction is this fraction, which is approximately 1.219. So there it is, to round it to 3 decimal places. And we can take a look at this. Does this seem reasonable? 0.57 about to 1.2. 0.57 is halfway in here, somewhere here for x. Y is 1.2 something. So I'm looking at a centroid somewhere, up in here. That certainly seems reasonable, right? If I'm getting a centroid down here or up here, that doesn't seem reasonable. Or obviously, if I get a centroid outside of the whole region somewhere, that's going to be incorrect. So check and see if it seems reasonable as well. Do that with homework, and that way, come test time, you'll be able to do that as well. Okay, hope this helps.